In this lecture, I'll focus the questions which are related to the application. So, angle of elevation, depression, heights, distances. These are the most common algebra problems. Let's start with the angle of elevation and depression. So, angle of elevation is looking up. So, you are at the ground, you are looking up at the tower, or maybe Vinay. Okay, and this is the angle which we call as the angle of elevation. But now let's say if you are already at a height, then you will calculate the angle of depression. Let's say you are, oh, sorry for why this height looks so odd. Let's do the for angle of depression that you are standing on the pool of Robbie. You're standing here, and there is someone who's traveling in a boat. This is a boat, kind of, and the person is traveling there. And when you look at this person, you have angle of depression, which can be calculated by drawing a straight horizontal line from your eyes and finding this angle. So don't confuse it with the angle of elevation with the person, with that would be different. But your angle is this one, upper one, not the downward one, which is phi. So if that person looks at you, it will have an angle of elevation, phi, but you looking downward have a theta angle of depression. Always use the right triangle. Just if you connect these, you will have a right triangle, and hence you can find the value here by using the right diagram. Let's do an example quickly. So for these type of questions, just quickly draw a diagram. So you may not make the beautiful tree. If you don't have time, but just draw a line for the tree, and you need to find this height edge. You know the shadow is 20 meters, so this shadow is 20, and you also have the angle of elevation. So the angle of elevation is always measured from the down side, so it will be this angle. If it were the angle of depression, which means you are looking down from upward, that would be this angle. All right. So that's angle for a bird is looking downwards. But luckily in this case we have angle of elevation that means looking up from the downward place. This is the angle which is 30 degrees, and we need to find the height. Now we can use sine theta in this case, uh, but for sine theta we need hypotenuse, which we don't have. Therefore, the tangent theta would be ideal. The opposite is height, adjacent is 20, uh, and the theta is 30 degree. Now to remember the value of tan 30, that's great. If you don't, just quickly write down the value of sine 30. You know, sine start from 0, so that 30 would be 1 over 2. And for cosine, it's 3 over 2. If you divide them, that means just leave it there. Because now you can see it's 1 over 3. But yeah, that's it. Now, after simplification, you can tell that height is 20 over 3. Now, the rag 3 can also be written down as 3 in the denominator and the rag 3 in the numerator. So if it's 20 over rag 3, and if you rationalize it by multiplying rag 3 on both, then you will get 20 times rag 3 divided by 3. So even if you have that kind of expression in the MCQs, know that the rag 3 over 3, this expression is equals to the 1 over rag 3. I chose the right one. So most examples, they have the same pattern, just that you need to use tangent for most distance and height-based problems. But you can also use sine and cosine for ladders or slanting surfaces, right? You need the value for, let's say, if this was a ladder from here to here, and you need the length of the ladder, and also you need to include the hypotenuse, and hence you will do sine theta or cosine theta depending on which values you have. If you have the value for adjacent, you will do cos theta, because cos theta includes the adjacent and hypotenuse. But if you have the wall length, then you would use the sine theta. So always draw the diagram first, simplistic diagram quickly, and remember that LGAT problems are formula based and direct.